Welcome back again, everyone. Hope you've all had a decent break, got some cup of coffee or whatever. Wish we could be offering you the coffee and goodies out in the lobby like we often do in the physical forum, but you'll have to forage on your own today. For our next presentation, um, we've got Jacqueline Arnold and Nick Cappy from PAS who will be presenting. I just also received a couple of new pieces of press materials that I'll be uploading to the virtual press room later this afternoon. So with that, I'm going to turn the microphone over to Jacqueline and Nick.
And welcome to this press briefing on Hexagon and PAS. In case you haven't heard the great news, PAS is now part of Hexagon. We were able to close the deal at the end of 2020. Very excited about working with PAS, and we've been really busy over the past few months working with them. This is going to help our clients together benefit from design all the way through maintenance in the control room and through cybersecurity. It actually broadens Hexagon's footprint, bringing PAS into the family so that we can expand within our strategic area of operations and maintenance. We've been focusing on that for the past 3 years, and we'll continue to focus on that area of growth. This broadens our capabilities to be able to add operational risk management, which is very complementary with some of our operational excellence J5 solutions. And we will be exploring how we can integrate Hexagon and PAS technologies to provide more benefit to our clients. And speaking of that, we are happy to announce we have our first integration already. At the first of the year, we kicked this off. So if you think about shift handover, our J5 solution that's shift excellence, which includes logbook and handover and work instruction, we have integrated this with PAS. Everybody on the shift, as you're changing shift, you need to know what happened, what's not working, what do you need to keep an eye on, where are the issues, where's the suboptimal areas of production. All of these are very key to avoid risk and keep the plants running. We've already integrated shift excellence with plant maintenance systems and historians to help automate some of the logging of events and ensuring that there's a follow-up and awareness as you have the handover. Now integrating PAS plant state integrity with our J5 shift excellence broadens that automation even more. So you've got more of a robust process around logging the current status of the unit or the operations in terms of alarms, boundaries, control systems, so that you have complete awareness and follow-up actions that are happening and tracked as you have shift handover. Nick, do you want to give us a few more details around this?
Sure. Leveraging our alarm management solution or our plant state integrity, we're able to capture frequency of alarms, shelved alarms, any process disturbances, or any IPL bypasses that are being bypassed as part of that handover process. As well as looking at the loop performance, looking at anything that's out of service, and that's really critical in that handover process to make sure all of those things are documented and understood by the next shift coming on.
Very good. And just a few last comments around this. This is using all out-of-the-box integration techniques. We've done a first layer to help clients understand the value between the two solutions integrated and the art of the possible of what else information you could be bringing into your handover and your logbook to streamline and add automation and reduce your risk. Okay, with that, I'll hand it over to Nick for the next part of our press release.
Perfect. Today, we're going to be talking a little bit about sensor data integrity, which is a new module released in our integrity platform, our automation integrity platform. And really what the sensor data integrity is focused on is managing the configuration data of sensors. And one of the problems, one of the big problems is that sensor data configuration resides in multiple sources. It could reside in a Hexagon Smart Plant Instrumentation database. It could reside in an instrument or an asset management solution. It could reside in templates provided by either the vendor or the owner operator as it relates to what is good configuration for those devices. It can reside in safety systems or PLCs or distributed control systems. And ultimately that data about that transmitter ends up residing or propagating its way up to historians and then ultimately into data lakes where business decisions are made of. And each of those different systems that I mentioned there are a different technology provided by a different vendor. And they tend to have different users of those systems. And each of those vendors or each of those users of those different technologies believe that their data they're looking at is the truth. But what we find out in a lot of our customer base is that that same sensor that resides maybe in an asset management solution as well as the DCS don't necessarily their data doesn't necessarily reconcile with each other. So there's multiple versions of the truth where each user is looking at their version as the truth. And the impact of some of those mismatches between data leads to things like unplanned shutdowns or at least unit upsets, startup concerns, uh, a lot of effort going around manually reconciling these data sources. We have one of our customers who has a team that basically is on a rotation from unit to unit, from facility to facility, whose whole job, or at least primary job, is to go out and reconcile all these sources of data so that when a decision is made, it's the right decision based off of the same data. And obviously that's costly and pretty error prone to maintain. Ultimately, these smart instruments were sold to you on the hopes of getting better diagnostics to do preventative maintenance or at least early fault detection. And what we see is that configuration within those systems, if it's not proper, those benefits are never realized. Ultimately, you also end up as these systems become more integrated and more connected together, you increase your attack surface, and now you have more risk out there that needs to be managed and understood. So you not only have to be able to understand it and know what you have, be able to make sure that all the configuration is the same with them, but you also have to be able to do a risk assessment or a vulnerability assessment across all of those different devices. So sensor data integrity, as I mentioned before, resides in the automation integrity platform. It's a multi-vendor technology, meaning we work with all of the major technologies, all the major automation systems out there in the world, whether your solutions are from Emerson or Honeywell or Yokogawa or Schneider. We work with those devices. And we bring all of both the online and the offline data together. We do the assessment looking for consistency across them and provide data visualization that takes you from the field instrumentation and shows you the data chain all the way up into a cloud solution where business decisions are being made of. The technology provides a auto discovery of these devices, these instruments within these different data sources. We provide configuration management, looking for defects within the system. And those defects could be either mismatches between the systems or bad configuration within them. We also have the ability to insert or import templates that define what good looks like within the product. We can also manage those templates within the application itself as well. But that allows you to create a standard to deliver on that the as promised benefits of putting in smart instrumentation, where you have the proper alerts set up and at least definitions of what those proper alerts should be. We're able to audit against that and see where you're either in compliance with your standard or not. We identify devices that don't have templates associated with them, which is pretty critical too, seeing that you may have tens or hundreds of thousands, if you're looking at this across an enterprise, of these smart instruments that need to be managed within the system. So being able to figure out which ones don't have a definition of good associated with them is pretty important. We want to be able to cross-check across the system. So looking at the DCS, comparing it to the asset management solution, comparing it to the as-built or as-designed system coming from SPI, and be able to cross-check things like ranges, engineering units, damper signals, any process variable manipulation that's going on within those systems. And we won't be able to, because there are large sets of these, and there are tens, if not hundreds of thousands of these devices across an enterprise, we need to be able to do that at a really large scale and across a whole variety of vendors and technology. And lastly, we want to be able to do the signal tracing, the genealogy of that signal from the instrument all the way up to the ERP, so you can see the impact of what the defects may be, or you can see the impact of a change. If I'm going to take this out of service, what might be impacted upstream? What business decisions might not be valid anymore while this is out of service? This is not another asset management solution, so we're not another AMS type technology, but we are able to be leveraged within that process where asset management solutions can help use our data to help them with collaboration or calibration, excuse me, making sure that the signals that they're looking at are represented across all the systems correctly. And the calibration settings that you're doing here match the range settings that are coming from the DCS. So we're an aid to those technologies, not a replacement for those technologies. And ultimately, since we have all of this data into the integrity platform, we're able then to do things like vulnerability assessment at level 0, and being able to take all of the instrumentations, these tens of thousands or hundreds of thousands of instruments, and do a complete vulnerability assessment against them, letting you know what risk that you may have out there from a security perspective. And I'm positioning it as security, but it could also be obsolescence. As things are coming to end of life, being able to allow you to run filters or queries against those data, those types of devices, to see how many of a given make, or model or version of a transmitter do I have across my enterprise. So that data could either be used for, again, vulnerability assessment or an obsolescence planning. As you see this data that's coming from these instruments, they start to move up into the environment, right? And or business decisions are made off of this data. And whether you're calling that Industry 4.0, or you're talking about a data lake or data cloud deployment, what you see is that you need to be able to make confident business decisions. And you can't have that with this huge manual effort that goes around with, at least I don't believe it's attainable, with a manual effort of reconciling these devices in the field. A, it's error prone, and B, it's costly, expensive, especially when you look at the reduction in force that's going on, or even access to sites now because of COVID. And so those things become even harder to get access to sites. You want to be able to improve the plant reliability, whether that's the uptime or the safety of the system, by reducing the number of trips due to bad configuration. So that's one of our key initiatives. One of our customers that's using this technology, before they did an audit, and they had a drift in their configuration of 40% of their instruments no longer matched what the good definition of that instrument was. And so they had spent all this money implementing all these smart instruments, set up all these alerts to get notified to do this preventative maintenance. But when they do the audit, 40% of those devices no longer match that definition of good. So it's really hard to recognize that value that you invested in those instruments, getting those back out through things like early fault detection or preventative maintenance, because you're not getting the proper alarms or alerts to the people to make those right decisions or execute on those actions. We want to enhance the data, obviously, that makes it up to the cloud or your data lake, to make sure that when business decisions are made at the top, it's based off of good data. We want to be able to leverage the sensor, the data that's coming in, not only from the reconciliation of these systems and making good business decisions, but there's also a security opportunity there to make sure that any risks that are associated with those devices are fairly well known and understood within the organization. And I mentioned earlier around the obsolescence planning as it relates to it. One of the side benefits of this comes from being able, especially on greenfield or brownfield migration projects, being able to help with loop checkout and accelerating that process. Because what we're doing really is finding all these inconsistencies within these data sources. So we're enabling the user, instead of going out and looking for problems, we're now enabling them to go out and solve the problems by executing on the things that we find that where the discrepancies are. So they're no longer looking at investigation, they're now looking at execution of projects, hopefully at a value add there from a time and resource standpoint. I believe that's my last slide. I don't know if there was any questions that came up in the process.
We haven't seen any. Oh, wait, no, we do have a couple of questions. I apologize. All right, Nick. All right, we've got a question. from Keith Larson. Most legacy sensor level communications protocols remain fundamentally insecure from a cybersecurity standpoint. Does SDI have any functionality to detect when a field device signal might be purposely manipulated and or corrupted?
No, so we're not online listening for the signal going back and forth, but what we are able to do is to take all of your transmitters or all of your smart instruments out in the field and do a vulnerability assessment for you. So being able to tell you where there's known weaknesses within those devices that could enable those protocols to be manipulated, whether that's man in the middle or whatever it may be. And so we're able to at least point directionally where those meters or those instruments may be vulnerable. I tell you what the relative risk is as it relates to a CVSS score, tell you the methods in which that are known to be exploited on those devices, whether that requires local access or network access, what type of permissions or credentials would be used to exploit those things. So we're able to provide that level of assessment against the risk or the security of those transmitters, but not in line detecting the protocols that are being used and whether that that communication is good or bad. Hope that answered the question.
Good. Thank you. We have a question from Greg Hale. Do you have a ballpark amount or average these sensor misconfigurations typically cost a company every year?
I don't, but I believe the ARC put a number out. I don't have the number off the top of my head, so you have to apologize, but there was an annual loss number that was put out by ARC a year or
Yeah,
two
Nick,
ago.
this is Larry of ARC. We actually did some research on the cost of unplanned downtime to the process industries. So while it's not specifically related to, was the cause a sensor or a valve, we do know that most of the time, for example, if a safety system is to fail, which rarely happens, but most of the time that happens, it's due to a valve or an instrument. We also estimated that the total cost of unplanned downtime to the process industries worldwide is easily over $1 trillion. It's very significant cost. So anything you can do to prevent that downtime is going to have a big impact, obviously.
Exactly.
Okay. I don't see any other questions, but we're curious if you had. Oh, wait. Here's another question. I'm sorry. Mark Hosky is asking, how much of these capabilities are from Hexagon and which are from PAS? Are the functions new, or the integration new? Please explain.
Well, so go ahead.
Okay, I'll go ahead and let you comment too, Nick. So for the integration, the functionality on both sides was already in place, and we simply used our out-of-the-box integration to bring in some of the plant state integrity into our handover. So some of the specifics that we're bringing into the handover are the logs and even the trends and reports around critical alarms that activated in the last shift, the last top 10 alarms for that shift, the previous shift, a list of the suppressed or shelved alarms, safety interlocks that may be in bypass currently at shift change, 10 of the most frequently changed parameters, so where you're having to babysit and watch the control more readily, control loops that are also in manual, and then process variables where you might be exceeding the operating limit or window. So these are some of the type things that the shift coming on really needs to know about to be able to reflect and have awareness about what they're taking on with the next shift and moving production forward. So Nick, did you have some comments on that too?
No, I think you nailed it. You hit exactly the topics that I was going to talk about. But around sensor data integrity, there's also an SPI connection, which was an existing connection for us. And so we are looking at enhancing and improving that as our partnership, or as we move into being one company. But there is ultimately, or was a connection between those, and that connection has existed for a long time.
Absolutely.
Good. Thank you. Okay. We've got, oh yeah, Mark thanks you as well. So thank you all around. Well, I don't see any more questions. So I'm going to thank the presenters for taking the time to speak to us today. And I'm going to thank our editorial participants for taking the time to listen today and to ask their questions. There are, once again, there are some materials in the virtual press room. Hopefully most of you have been able to get into those, access the press room. If not, keep sending me emails. We'll work out those issues. And feel free to visit to visit our speakers at the virtual exhibit during this virtual week. So thank you. I'm going to remind our editors that we have another presentation starting in about 20 minutes. And thank you all. Take care.
Thank you.
Thank you.